Hello everyone. I am Abhishil Anand, and I'm a final year undergraduate from Bharati Vidyapeeth College of Engineering, New Delhi. So today I'll be presenting my paper, Gauntlet. Basically, it's precise finger and hand movements capturing variable. And the co-author of this paper is Bhavana Chaglani, who is also an undergraduate student. So as you all know, capturing finger and hand movements can be very useful in a wide range of applications, as you can see, in like understanding sign language and AR/VR applications. But there are several unexplored areas in like analysis of bowling patterns and etc. So they have like they require precise joint motions uh, measurement for the analysis. So for now what we have, so the state of art approaches we have divided into two parts. One is non-variable and another is variable techniques. So in non-variable, one major is vision. So in vision, they use camera and deep learning models to identify finger movements and hand gestures. So, and this technique is called EchoFlex, and it uses ultrasound imaging and plus machine learning to detect several static gestures. And this is called visible light sensing. So it uses LED lamp and photodiodes to detect hand postures. And the methods like radar are also famous for the same. Now, coming to the variable-based approaches, many researchers in the past have used flex sensors. So flex sensors are nothing but they are a conductive strip, and their resistance change when they are bent. So they use that fact, and obviously they use IMUs and linear potentiometers as well. So in the these three techniques they're being used extensively by researchers. And coming to the recent interest, so many researchers have show their interest in capturing or classifying hand activities and fine grain gestures by using smartwatch. So what they do, they upscale the sampling frequency of accelerometer, and with the help of that, they are able to classify those gestures. And there are several commercially available uh, products as well. What they do, they detect the electrochemical signals generated by the muscles, and with that, they are able to classify several gestures. So, but coming to the non-variable approaches, the problem is they are very infrastructure based. So they cannot be used everywhere. And for the variable based approaches, so we have find out the basic requirements for an efficient variable based approach. So for the first, it should have unconstrained hand movements, should provide unconstrained hand movements, and it should be lightweight, and obviously it should be highly accurate. It should perform a real-time operation, and it should be able to detect every joint movement, and it would be very good if it is low cost. Yeah, so as you can see in this, there are existing variable-based techniques. So most of these techniques are performing the processing on basically off board, basically on a nearby system, on a laptop or something. So it that introduces dependency and delay also. Apart from that, uh, they are not cost effective, and they are not able to detect every movement, every joint movement of the hand. So here we come. So his gauntlet, it's a seamless and a lightweight variable to detect every joint motions of the hand. Coming to the variable design, we have put 13 assembly rotary potentiometers at each joint of the fingers of the hand, and placed an IMU at the back of the hand to get the orientation and position. So because we have put potentiometers on each joint, so we are able to get precise joint motion directly from the joint itself, and we can we can also get fine-grained joint finger movements with the help of that. Now, in many wearable designs, in the previous wearable designs, we have seen that what they prefer, they consider that that DIP and PIP movements are related to each other. DIP is distal phalanx and PIP is proximal phalanx. But however, there are several cases in which several less but important cases in which these movements occur differently, and they are need to be analyzed. So if this variable is able to capture those movements as well, separately as well. And so what components do we have? So I've already told you we have SMD potentiometers, SMD rotary potentiometers, and an MPU 6050 as an IMU. And it's a quite powerful microcontroller ESP32 and a lithium-ion battery at the back of the wrist. So how does it work? So 13 potentiometer readings are taken via ADC, and 6 IMU values, that is XYZ of accelerometer and gyroscope, are taken by ESP32 microcontroller at 200 hertz simultaneously. And for the gesture classification part, we are running TensorFlow Lite models on ESP32 microcontroller itself for the gesture classification. Coming to the gesture recognizing pipeline, so obviously we need to have some data set. So for that we took help from 10 volunteers, and we captured 300 entries for each gesture, and those entries were those data set entries were made using potentiometer readings, IMU values, and obviously the label of that gesture. Now what we did, we trained a state vector machine classifier on the laptop using TensorFlow, and then we deployed that trained model on ESP32 using TensorFlow Lite, which is designed for these type of devices. And finally, we do the prediction on ESP32 microcontroller itself using TF Lite. So for the gesture, for training and evaluation, what we did, we took 5 similar looking gestures from a American Sign Language. Why I'm telling you similar? Because all of these gestures use 2 fingers, a thumb, and an overall orientation of the hand to differentiate from each other. So we got this is a confusion matrix of SVM for those 5 gestures, as you can see. And NG obviously means no gesture were detected. So now what we get to know that our system is not able right now was not able to detect the gaps between the fingers. So that's why, and in the gesture R, so the 2 fingers, the index finger and a middle finger and the index finger, are close to each other, and above else they are overlapping with some degree. So that's why our system shows poor results in classifying the gesture R, and that's why the confusion between R and B, does all that. But this is because it is able to detect R, because then also there are slight difference in the joint angles while doing the gesture R. It is able to detect that too. So as you can see, the proposed system Gauntlet basically outperforms the previous techniques by in the cost effectiveness, because basically potentiometers are very inexpensive, and in case of precision and delay as well, it outperforms the other existing techniques. And it's also lightweight. The weight of the variable is around only 55.4 grams approx. So for the contribution, we developed a low-cost seamless variable that can sense finger joint movements, position, and orientation of the hand precisely. We have used a low power, low latency edge classification approach that facilitates real-time gesture classification. We identify various applications where this variable will be a best fit. For example, that the example I told you, cricket bowling analysis, and also we can use the system in bikers analysis, basically is braking and accelerating patterns. So yeah, for the future work, we would like replacing ESP32 with even basic. ESP32 is actually a powerful device, and we like to replace it with more resource constrained device like Arduino Nano. So that would be possible if we use Proton and algorithm. So it's a novel algorithm and a KNN based algorithm, which is specially designed for these type of microcontrollers, and it will improve the battery life of the variable significantly. And yeah, we have to still have to do the system evaluation for dynamic gesture and coarse and fine-grained hand activities as well. Yeah, and we had to also evaluate the system for the gestures when they are performed while walking or running or some other task. And yeah, of course, we'll be improvising the design by placing 3 potentiometers between the 4 MCP, so that the just glove is able to detect gaps in the finger as well. Thank you.